Beneath the streets you walk on every single day, there is something most people never think to question. Not traffic tunnels, not sewage pipes, not abandoned basements, but infrastructure. Systems buried so deep, so vast, and so precisely constructed that they resemble something modern cities still struggle to build today. Official history tells us that before electricity, cities were simple, energy was local, lighting was weak, power was limited. We're told that large-scale underground systems only became possible after generators, electrical grids, and modern engineering. But that explanation collapses the moment you look beneath the surface, because beneath many of the world's oldest cities, there are networks that do not behave like early experiments. They behave like mature power systems. It's stone-lined conduits stretching across districts, massive underground chambers positioned with intention, vertical shafts rising through buildings as if designed for airflow, heat, or pressure. These are not random holes in the ground. They are not accidental remnants. They are organized. And that's what makes them unsettling. Because infrastructure always reflects capability. You don't build systems at scale unless you understand them. You don't bury complex networks beneath cities unless you expect them to last. And you don't standardize design across vast areas unless the system is meant to function as a whole. Yet, according to history, the societies that built these cities were not supposed to have that level of power, literally or technologically. That contradiction is what pulled me into this investigation. At first, I assumed there had to be simple explanations: drainage systems, early heating experiments, primitive utilities exaggerated by time. But the deeper you look, the less those explanations hold. These systems are often overbuilt. Walls thicker than required, chambers larger than necessary, access points placed where no modern utility needs them. Overbuilding only happens when designers anticipate heavy use or long-term importance. And what troubles me most is this: many of these underground networks appear older than the streets above them. Cities didn't dig down to install them, they built over them, which raises a question history rarely asks. If electricity didn't exist yet, if modern power hadn't been invented, then why do so many old cities sit on top of systems that look like they were designed to distribute something? Energy, heat, air, or something else entirely. This is not about claiming lost technology or rewriting history. It's about acknowledging something much more uncomfortable: that our cities may be standing on infrastructure we no longer understand. Infrastructure that didn't disappear because it failed, but because its purpose was forgotten. And once you see that, you can't unsee it, because the streets above suddenly feel less like foundations and more like coverings. Official history gives us a very clean, very comforting story. Before electricity, cities were dim, power was limited, technology was local, mechanical, and inefficient. Lighting came from gas lamps, heating came from coal and wood, ventilation was passive, crude, and largely accidental. According to this narrative, underground space served only a few basic purposes: drainage, sewers, storage, occasionally cellars or foundations. Nothing more, nothing complex, and certainly nothing resembling a unified system. At first glance, that story seems reasonable. It's what we were taught. It fits neatly into a timeline where progress moves forward in a straight line. But the moment you step below street level, the story begins to fracture. Because what we actually find underground does not behave like early infrastructure. In city after city, beneath streets laid long before electrical grids existed, we find networks, not fragments. Tunnels that maintain consistent dimensions across large distances, chambers positioned at repeating intervals, vertical shafts aligned through multiple building levels as if designed to connect something above and below. This isn't improvisation. This is planning, and planning implies understanding. Official explanations usually rush in at this point. These were just sewers, early steam systems, ventilation shafts, old heating experiments. But when you compare those explanations to what's physically there, the mismatch becomes obvious. Sewers do not require symmetrical chambers large enough to walk through. Ventilation does not demand stone-lined tunnels built to architectural standards. Heating systems do not explain vertical shafts running straight through entire buildings, aligned floor to floor, sometimes capped with decorative elements. What strikes me most is how often these structures are over-designed. In engineering, over-design isn't accidental. It's expensive. It consumes labor, materials, and time. A society struggling with limited technology invests that much effort into systems meant to be crude or temporary. And yet, official history insists that's exactly what happened, that people with horse-drawn transport and manual tools somehow constructed underground networks that rival modern infrastructure in scale and durability, and then forgot about them. I used to accept that explanation, until I started noticing something else. These systems aren't scattered randomly. They're positioned strategically. Chambers appear beneath major intersections. Shafts align with large buildings, public halls, and former industrial zones. Routes follow patterns that mirror surface-level organization. That's not how waste systems are laid out. That's how distribution systems behave. And this is where the official narrative begins to feel less like an explanation and more like a dismissal. Because instead of asking what these systems were actually doing, history assigns them the closest familiar label: sewer, basement, utility, and moves on. But labels don't change structure. If something looks like a system designed to move energy, pressure, or flow across a city, then calling it a drain doesn't make it one. Another uncomfortable detail rarely discussed is timing. In several cities, their records show underground systems existing before the technologies supposedly required to operate them. Before centralized electricity, before modern boilers, before standardized engineering education. Yet, the construction quality suggests knowledge far beyond trial and error. Precision stonework, underground, uniform dimensions across kilometers, alignment that assumes long-term integration with surface architecture. This doesn't mean history is lying. It means history may be simplifying, and simplification is dangerous when it replaces curiosity. Because once an explanation becomes comfortable, questions stop. And when questions stop, structures like these fade into the background, present but unseen. What troubles me personally is not the idea that something was hidden. It's the idea that something was misunderstood and then quietly ignored. Cities don't accidentally build massive underground systems. They don't accidentally standardize design across continents. And they don't accidentally forget why they did it. Something changed. Either the systems stopped being used or the knowledge required to understand them did. And once that happened, future generations inherited the structures without the context. They saw tunnels and chambers without purpose. They labeled them. They sealed them. They built over them. And the story was rewritten to fit what remained visible. What official history tells us is neat. What the ground beneath our feet tells us is not. And the deeper we go, the harder it becomes to pretend those two stories are the same. Once you move past labels and look at these underground structures as physical systems, one problem becomes impossible to ignore. Scale. A small tunnel can be explained away. A single chamber might be dismissed as an anomaly. But scale changes everything. Beneath many old cities, these systems do not exist in isolation. They extend across districts. They branch, reconnect, and repeat. This is not the footprint of a local solution. It is the signature of a network. And networks are expensive. They require planning before construction ever begins. They demand coordination across multiple sites. They assume long-term use. In the 19th century, Digging underground was one of the most difficult forms of construction imaginable. No electric tools, no modern ventilation, no powered excavation equipment. Every meter of depth increased risk. Every tunnel required manual labor, lighting, structural support, and constant maintenance during construction. Now, consider the size of what exists. Tunnels tall enough for full human movement, chambers large enough to stand in comfortably, corridors reinforced with stone rather than wood. These are not survival structures. They are designed environments. And that is where the problem begins. If these systems were purely experimental or temporary, they would be minimal. They would cut corners. They would rely on cheaper materials. But instead, we see the opposite. Heavy stone walls, precision-cut masonry, uniform dimensions maintained over long distances. From my perspective, this is where the explanation truly breaks down. Because large-scale complexity without clear necessity does not happen accidentally. Complex systems exist for one reason only. They solve an important problem efficiently. And yet, official history struggles to identify the problem these systems were meant to solve. Waste disposal does not require this level of architectural discipline. Ventilation does not demand standardized chambers across entire cities. Heating does not explain the repetition of access points and vertical shafts. At some point, the explanation stops scaling. What might make sense for a single building becomes absurd when multiplied across a city, and when multiplied across multiple cities, it becomes impossible to ignore. Another factor rarely discussed is coordination. Underground networks do not build themselves gradually without consequence. You cannot simply add tunnels randomly and expect them to align. You cannot dig beneath streets without impacting surface structures. You cannot integrate underground systems into buildings without planning them together. Yet, these systems appear integrated. Basements align with tunnels. Shafts pass cleanly through foundations. Access points correspond to building layouts. That means decisions were made early, before streets were finalized, before buildings reached their final form. Which raises a disturbing implication that the underground system came first, or at least alongside the city itself. This is where I personally find it hardest to accept the conventional timeline, because cities are usually built upward, not downward. You don't dig extensively beneath a city that doesn't yet exist. You don't create deep infrastructure before you understand what it will serve, unless the system already existed, or unless the city was planned around it. And once that possibility enters the picture, everything shifts. The underground stops looking like an accessory. It starts looking like a foundation, not just structurally, but functionally. One more detail reinforces this. Many of these underground systems show signs of maintenance. Reinforcements added later. Sections repaired rather than abandoned. Entrances sealed carefully, not destroyed. This suggests continued relevance. You don't maintain systems that never mattered. You don't repair infrastructure that was always useless. Something changed. The system lost its function, but not its value. And when that happens, societies rarely tear such systems out. They bury them. They build over them. They let memory fade. The scale of these underground networks forces a difficult conclusion. Either pre-modern cities invested immense resources into systems they didn't need, or these systems once served a purpose that no longer fits our historical narrative. And when history and physical evidence disagree at this level of scale, it is the evidence that deserves closer attention. There is a moment when these underground systems stop feeling static. At first, they look like empty spaces, stone corridors, silent chambers. But the longer you study them, the more they begin to feel active, not in a mechanical sense, but in the way they are shaped. Because shape tells us how something was meant to function. These tunnels are not dead ends. They curve, they branch, they reconnect. This is the geometry of movement, Flow does not require electricity, it requires understanding. Air moves through pressure, heat moves through difference, energy moves through channels, and many of these underground systems appear designed to guide movement, not prevent it. Ventilation shafts are one of the clearest examples. They rise vertically through buildings. They are evenly spaced. They terminate at predictable heights. This is not how storage spaces are ventilated. This is how systems that generate or manage heat behave. From my perspective, this is where the structures start to look less like infrastructure and more like organisms. They breathe. Air inlets, air outlets, pressure relief. Even the chambers themselves feel intentional. They are not cramped, they are not irregular, they are shaped for circulation. If you stand in one of these spaces, the acoustics are telling. Sound travels, echoes behave predictably. Air moves. These are properties that engineers pay attention to when designing systems meant to handle energy, not waste. Another detail is access. These systems are not hidden in the way forgotten spaces usually are. They were accessible, serviced, maintained. Hatches, doorways, passageways wide enough for people to move equipment. This implies use, and use implies purpose. At some point, I stopped thinking of these spaces as abandoned. They feel paused, as if they once operated under rules that no longer apply. We often assume that energy requires electricity because that's the world we live in. But energy systems existed long before wires, heat networks, pressure systems, fluid dynamics. Cities understood these principles intuitively. And when you look at these underground networks through that lens, they begin to make sense, not as power plants, but as distribution frameworks, channels designed to move something efficiently across a city, air, heat, or something we no longer recognize. This does not mean they powered cities in the way modern grids do. It means they were designed with function, not just containment, in mind. And this is where the unease sets in, because once you recognize flow, you can't unsee it. The tunnels stop looking random. The shafts stop looking decorative. The chambers stop feeling excessive. They start looking necessary. And necessity implies intent. Intent implies knowledge. And knowledge implies continuity, which leads to the next question. If these systems were designed to move energy, why did they stop? There is a point in every investigation where explanations stop feeling reassuring, not because they are proven wrong, but because they no longer explain enough. For me, that moment came quietly. It wasn't a single discovery or a dramatic realization. It was repetition, city after city, structure after structure, the same underground logic appearing again and again. At first, I was comfortable accepting conventional explanations, early infrastructure, primitive utilities, misidentified basements. Those explanations work. Briefly, they work when you look at one tunnel. They work when you isolate one chamber. They work when you avoid looking at the system as a whole. But once you start seeing the entire network, something changes. The explanations don't collapse. They thin out. They become vague. They become conditional. They rely more on assumption than evidence. And that's when doubt sets in. What stands out to me is not mystery. It's consistency. Different cities, different countries, different historical contexts, yet the same patterns repeat, the same scale, the same geometry, the same emphasis on flow, access, and durability. That level of consistency does not emerge from improvisation. It emerges from design, and design requires intent. I don't claim to know what these systems powered. I don't claim to know who built them or why they disappeared. But I find it increasingly difficult to believe they were meaningless, because meaningless systems don't survive. They're torn out, they are ignored, they are forgotten entirely. These were not. They were sealed carefully. maintained selectively, integrated into later construction. Cities adapted around them, and adaptation is what societies do when removal is harder than reuse, or when something is still useful, even if its original purpose is no longer understood. This is where the timeline starts to feel strained. If these systems were built for needs that vanished, why does history rarely acknowledge that transition? Why is there no clear moment where cities say, "This no longer works. We're replacing it"? Instead, we see quiet reclassification. Power systems become tunnels, distribution networks become basements, access shafts become architectural curiosities. The function disappears. The structure remains. That kind of transformation usually happens when knowledge is lost, not when it is replaced. From a human perspective, that's unsettling. It suggests that cities may inherit infrastructure they no longer fully understand, and rather than confront that uncertainty, they normalize it. They rename it. They build over it. They move on. I don't believe this was done out of deception. I think it was done out of practicality. Cities don't stop functioning while waiting for perfect explanations. They adapt, and in adapting, they simplify the story they tell themselves. What makes this uncomfortable is realizing how easily that story becomes permanent. Once a generation grows up assuming underground systems are just basements or sewers, curiosity fades. The question is no longer asked. And when the question disappears, so does the investigation. What remains is stone, alignment, geometry, flow, physical evidence that doesn't argue, it simply exists. And at some point, the burden of explanation shifts. It's no longer on those who question the narrative. It's on the narrative itself, because when physical systems repeatedly contradict the story meant to explain them, something needs re-evaluation, not conclusions, assumptions. And that is where this investigation now stands. Not claiming answers, but no longer satisfied with explanations that stop working the moment you look too closely. At this point, the goal is no longer to find a single answer. It's to recognize that the question itself matters. The underground systems beneath our streets are not theories. They are physical, they are measurable, they are still there. What remains uncertain is how we interpret them. Official history offers one interpretation, observation suggests another, and somewhere between those two perspectives lies a space worth exploring. What if these systems were never meant to be forgotten, only repurposed? What if they weren't abandoned because they failed, but because cities changed faster than understanding could keep up? Civilizations don't always lose technology through catastrophe. Sometimes they lose it through transition. A system becomes obsolete. Its operators move on. The knowledge becomes specialized and then unnecessary. Over time, what once made sense no longer fits the present, and instead of preserving its meaning, society preserves only its shell. This does not require lost civilizations or hidden empires. It only requires acknowledging that history is selective. It remembers what remains useful. It simplifies what doesn't. The underground power systems beneath our streets may not represent forgotten brilliance, but forgotten context. And context changes everything. If these systems were designed to move energy in ways we no longer recognize, that doesn't mean we were more advanced. It means we were different, and difference is often harder to record than progress. The real value in examining these structures is not uncovering secrets. It's learning to question assumptions we rarely think to challenge. Why is this here? What problem did it solve? Why does it appear everywhere? Those questions don't undermine history. They strengthen it, because history is not fixed. It is refined. If this exploration made you look differently at the streets beneath your feet, that curiosity is the point. In future episodes, we will continue examining underground infrastructure, architectural anomalies, and historical patterns that don't fit neatly into the timelines we inherited. not to offer final answers, but to document what remains unexplained. Because sometimes the most important discoveries aren't hidden. They're simply unquestioned. Stay observant and keep asking why.